Two blocks M1 and M2 are resting on a horizontal surface. There is no friction between lower block and surface, and coefficient of friction between blocks is mu. So here between two blocks there is a friction here. A force F is applied on the lower block in a horizontal direction. Maximum acceleration of the system. Here, first point here is frictional force is self-adjusting force. So here, frictional force depends upon applied force till certain stage. So here, if you apply a force, because friction exists between these two blocks, block M2 will not allow block M1 to move forward direction. Here between them normal reaction. So this opposes relative motion. So frictional force acts on M1 is mu into N. This is limiting friction. Frictional force can be less than this. So the maximum force in reaction, M1 also will exert a force on M2 that is also given. So this is the maximum frictional force. So after that, if you increase the force, this maximum frictional force remains the same. F will increase, then blocks will move separately. So here he said blocks will move together. So blocks will move together if, so here maximum force acts on M2 will be mu s mg M2g, which is M2a. That means A equal to mu. Right. Till that they move together. If applied force still increases, then frictional force on M2 will not increase. This mu n will not increase. Here, net force on M1 increases. M1 and M2 move separately. Here, calculate the electrical flux by Gauss law. Electrical flux is Qn by epsilon naught. So charge kept inside the Q is this. So epsilon value 8.85 into 10 power minus 11, which is 10 power minus 12, which is 10 power 5 Newton meter square per coulomb. An object of mass m is taken from the surface of the earth to a height 3r from the surface. So here it is. Initially, object mass m is at a distance are from the center of the earth, then potential energy at A will be minus gmm by r. When it is taken to a height r, now potential energy at B will be minus gmm by, it's a distance from the center to that. From surface it is 3r, from center it is 4r. So the work done is potential energy at B minus potential energy at A. So plus gmm by r, which is 3gmm by 4r. We know that g here is gm by r square. So here it is which is equal to gr square into m by 4r. It cancels, so 3 by 4 mgr. Here the relative velocity between layers, that is dv, which is perpendicular distance, that is dz, 0.2 centimeters. So velocity gradient is d by dx. So 10 by 0.2, which is 50 seconds. Here 100 gram of ice at 0 degree centigrade is dropped into a calorimeter. Here 100 grams of ice at 0 degree centigrade is dropped into a calorimeter of water equivalent is 50 gram. So this calorimeter already containing 100 grams of water at 40 degrees centigrade. So here cold body, this is cold body. So this is hot body. So what is the energy associated with the hot body? By taking reference as 0 degree centigrade, 100 grams of water, specific heat 1, and temperature is 40. It is 4,000 calories. So about calorimeter, so again ms delta T, he told its water equivalent is 50 grams, then delta T is 40, that is 2,000 calories, 6,000 calories. But here, to convert 100 grams of ice to water at 0 degree centigrade, we require 8,000 calories, but we have totally 6,000 calories available. Total ice cannot be melted. So the resultant temperature will be at 0 degree centigrade. Here, two simple harmonic vibrations One is y1 3 sine omega t, other is y2, it is 4 cos sine 90 plus theta cos theta. The resultant amplitude, once they superimpose, so equation of SHM is this. So resultant amplitude is root of 9 plus 16. Your standing wave is produced in 12-meter long stretched string. If the string vibrates, it vibrates in 6 segments. Then wave here, frequency is asking. Frequency here is can be calculated by using V equal to n lambda. So distance between these two nodes is lambda by 2. Like that we have 6 segments. 6 lambda by 2 will be the length of a string. Lambda here is 4. Frequency will be 5 Hz. A de Broglie wavelength of a particle is calculated by using formula h by p. So here it is nothing but this p is momentum, p square by 2m is kinetic energy. So here it is h by 2m kinetic energy, which I can write it as 2m into qv. Now here he given if it is accelerated with this potential, then wavelength is 1 angstrom. So here h is constant, m constant. So here charged particle also constant. Lambda is simply dependent upon applied potential. Lambda 1 by lambda 2 is V2 by V1. So which is 800 by 200, which is 4 times we get 2. So lambda 2 will be, so lambda 1 is 1, so 0.5 angstrom units. The maximum kinetic energy, so Einstein photoelectric equation is equal to h nu, no, h nu here is h nu naught plus kinetic energy maximum. The stopping potential is equal to V E into V, which is equal to kinetic energy maximum. He told photoelectrons emitted from the surface fall on it is 6 electron volts. So the stopping potential is 6 volts. So here galvanometer resistance is 100 ohms. A shunt of 5 ohms is connected to convert into an ammeter. So when shunt is connected parallel to the galvanometer, this whole system we call it as a ammeter. So the resistance will be 100 into 5 by 100 plus 5. So here it is roughly 25, maybe 4.8 ohms. Two capacitors, each having capacitance 4 microfarad. Breakdown voltage for this capacitor is 24. That means maximum charge can be accommodated 4 into 20, 80 microcoulombs. So when they are connected in series, effective capacitance will be 16 by 8, 2 microfarad. Since they are connected in series, same charge flows through it. So here breakdown voltage Q by C, 80 microcoulombs by 2 microfarad, that is 40 volts. Electric field in a region, electric flux through the surface. So surface here is a circle. Electric flux is calculated using phi equal to E dot A. Area vector is perpendicular to the surface. This x square plus y square equal to 4 represents a circle in xy plane. So area vector will be normal to the surface. So that area vector is k bar. K is a unit vector along z-axis. So now phi is equal to E dot, but here magnitude of this will be pi r, area is pi r square. So it's only a direction, area, it's only a direction point of view. Area is pi r square, where r square is 4 units. So 4 pi k. E dot 4 pi k, which is 2i plus 4j plus 3k dot 4 pi k, which is 12 pi. We given it as 8 pi. Value of k is 12. Here, number of turns in primary coil, number of turns in secondary coil. So induced EMF in primary coil is equal to minus NP d phi by d. Induced EMF in secondary coil here we write AP by ES NP by NS. So here EP is input voltage, right, by the output. Primary 50 turns, which is 200 volts. If two bulbs of same voltage rating consume a power 60 watts, so once they are connected in series, effective resistance changes. P here is your voltage rating is same, only resistance changes. So R1 plus when they are connected in series, six V square plus 16 V square by 6. So here power consumed by the combination, that is 600 by 16, which is 37.5 watt. So induced EMF d5 by dt, phi here is, which is 40 plus 2, at equal to 2, 8 plus 2, that is 10 ohms.